All right, we're going to continue on and look at number 4. Number 4, they are rational equations, so the name is solve rational equations. The description would be multiply and kill the fractions. And since we've done the kill the fractions before, that'll make this a little bit easier. And then solve the new equation. Okay, when we killed the fractions in the first semester, we would find the least common denominator and multiply every term by that least common denominator. So that's what we're going to have to do. This can get kind of tricky, especially if the denominators are maybe more complicated expressions. Okay, we're pretty lucky with these two right now. So I think he's kind of trying to start you off maybe a little smaller to kind of get the feel for it. So we've got denominators of 4x, x, and 2. So my advice is to look at the numbers first, the 4 and the 2. So just think of the least common multiple that you can get out of 4 and 2. What would that be? Least common multiple would be 4. So we're lucky that 2 goes into 4, so we can just use one of the numbers that's actually already there. So we're going to use a 4. And then the variables, we've talked about this before. When you had to find the least common multiple, you use the greatest amount of the variable. So we have a 1x, a 1x, and a no x. So the greatest amount would be a 1x. So my least common denominator would be 4x. And once you figure that out, that's what you're going to multiply and kill the fraction with. So that's telling me that I'm going to take 4x times this whole thing. So I'm going to kind of do that off to the side so that I can show you what happens here so that you know. So I'm going to take 4x times 2 over 4x. That's my first term, my first distribution. So the 4x that we're multiplying with, is really over 1. The good news is that this 4x and this 4x cancel out completely, leaving just 1's. So when I multiply 4x times 2 over 4x, what's my result? Just 2. So that first term is 2. Okay, plus, let's take 4x times 3 over x. So my 4x is over 1. Can I cancel anything? Just the x's. So I'm canceling that x and that x. And since that's it, what's my result there? 12. Okay, and then I've got 4x times my 1/2. And that's over 1. Anything cancel out here? The 2 and the 4 become a 1 and a 2. So what's the result of that? 2x. Okay, so now when I do this problem, my 2 plus 12, go ahead and do that. 14 equals 2x. Divide by 2, and x equals 7. Now, there's one thing that you have to look for, and he has not talked about it at all in any of the things that I'm seeing, but I can't let you go without realizing it. There are these things called extraneous solutions. Okay, so somewhere, I'm going to actually up here, and this isn't part of your description, I'm just telling you to write this kind of as a note to yourself. Look for extraneous solutions. That's solution there. Look for extraneous, extraneous. And what that just means is you can't end up with a 0 in the denominator of any fraction because that's completely undefined. So if a value would end up giving you a 0 in the denominator, you couldn't include that value. It's really not a solution. It's something that worked out in the problem, but it's really not a correct answer. Now, the only thing that we would have to worry about on this particular problem, do you know what number would make a denominator 0 in this problem? Anybody got any ideas? If x was what? If x was, no, 0. If you would have solved this and it came out to x is 0, you'd have to say that was an extraneous solution, because in this one, it'd be 3 over 0. You can't have 3 over 0. And then this one, it'd be 2 over 0. So you just kind of have to be aware that that could happen. So you kind of have to check your answers at the end and make sure that it doesn't come up to anything that isn't good. All right, let's move on. I tell you what I'm going to do. I'm going to pause here for a minute. All right, 4b, this problem, 5 over x plus 3 over 4 equals 1 over 3x. We've got to find the least common denominator. So we would look at our 4 and our 3 and think of the least common multiple of 4 and 3. What would that be? Jordan? 12. And then I look at my x's, and there's just an x by itself in the first term and a 3x in the second term, so I would have to use an x. So to kill my fraction, I'm going to multiply by the least common denominator of 12x. How many people got that as what they were going to kill the fraction with? Good deal. Okay, so let's do this step by step. So I've got 12x times 5 over x. Just remember your 12x is really over 1. Anything cancel out here? The x's. So that when I go ahead and multiply this, what do I get? 60. Okay, so we're going to go over here, put my 60 down for the first term. All right, plus, now I got to take my 12x times 3/4. Put my 12x over 1. Anything cancel in this step? The 12 and the 4 become a 3 and a 1. So when I multiply it over, I get 9x. So 9x, change my color back here, equals, and now let's do 12x times 1 over 3x. Anything cancel? Yep, so the x's cancel, and the 12 and 3 become a 4 and a 1. So my result on this one would be what? 4. Okay, so my new equation is 60 plus 9x equals 4. I'm going to subtract 60. 9x equals negative 56. Divide by 9, and x equals negative 56/9. Just leave that improper. Would that be an extraneous solution? No. What would be the only extraneous solution in this equation? Again, it would be, it couldn't be a 0, right? That's my extraneous solution. If it came out to 0, you'd have a problem, but it didn't, so we're good. Negative 56 over 9. How many people got that on their own? Anybody? Okay, looks good. All right, is there anybody that needs the writing, or can I move on? Okay, good deal. Let's go on to number 5. All right. So, number 5. Number 5 says simplify the square root of 20 for 5a. So this is simplifying a radical expression. So simplifying a radical expression. And basically what they want us to do is to factor out perfect squares and then bring perfect squares out as square roots. Okay, so you're going to look inside that radical sign and you're going to factor it out, or factor it down so that there's perfect squares out of there. You're going to bring the perfect squares out in front of the radical sign as its square root once you bring it out. So let's look at radical 20. Think of the largest perfect square, and that's kind of the key. It's got to be the largest one. It just can't be any. The largest perfect square that's a factor of 20. What is it? 4. So this would break down to 4 times 5. So that is radical 4 times 5. So then it says bring the perfect squares out as square roots. So what is the square root of 4? So 2 comes out in front and 5 stays inside. Alright, now I'm going to do this one with you because it's got letters and it's a little bit different. So let's look at radical 18, a to the third, b to the fourth. Question. What? Oh, that's right. So I've showed you that, didn't I? Oh, well then, okay. All right. So let's do one step at a time. Oh, one step at a time. 18, what's the largest square root? Or, I'm sorry. Largest perfect square that's a factor in 18? 9. So you take 18 and make it 9 times 2. Now, any variable is a perfect square as long as the exponent is even. But a to the third is not even. So here's what you do with that. You take out the largest even amount that you can. In this case, 2. And then you've got 1a left over. That's how you end up with your 3. You factored out the perfect square. And then b to the fourth, well, that's even, so that's a perfect square. So I've got this broken down to perfect squares plus the extra factors that are involved. So let's go one step at a time. So I've got the 9. We can do square root of 9 and bring it out. What is it? 3. Okay, I'm going to put my square root here. So I've taken care of that 9. The 2 isn't a perfect square, so it's staying under the radical sign. So I'm done with that. A to the second. It's a perfect square. When you bring a perfect square variable out, its square root is just half of the exponent. So if I bring a squared out, I'm just bringing out a. That other a, it's left there. B to the fourth. That's a perfect square. What do you think I'd bring that out as? Mackenzie? B squared. So we've taken care of all of them.